In the present video, we will discuss the example problem on deformation of a bar subjected to axial forces. Let's see the problem. A circular bar ABCD is rigidly fixed at A and D and is subjected to axial forces as shown in the figure. Determine the reaction forces, the forces in each portion of the bar and the displacement of point B and C. Take Young's modulus E equal to the 200 kN per mm square. In this problem, we have to determine the reaction forces R1 and R2 and forces in each portion of the bar, that is PAB, PBC, PCD. Moreover, we have to determine the displacement at points B and C, that is delta B and delta C. Let's see the solution. First, to draw a free body diagram of a portion AB. Here, reaction force R1 is acting at the left hand side of the body, and let's consider R1 equal to the PAB. So, to maintain the equilibrium, right hand side also generate the same amount of the force PAB. So here we have to observe the nature of force is the tensile force. So force is acting as the PAB and length of the AB portion is LAB equal to the 1500 mm and cross sectional area of the portion AB, that is AAB, equal to the 1000 mm square. Next, we have to draw a free body diagram of CD. Here, reaction force R2 is acting at the right hand side of the body, and let's consider R2 equal to the PCD. So maintain the equilibrium, left hand side also generate the same amount of the force, that is PCD. Here, nature of the force is the compressive force. So force is the PCD and length of the portion CD is LCD equal to the 1500 mm and cross section area of the portion CD is ACD equal to the 2000 mm square. Next, we have to draw a free body diagram of portion BC. Here, force 80 kN is acting at left hand side of the portion BC. Moreover, another reaction force of PAB in the opposite direction in the portion AB is also acting. So, net amount of the force is 80 minus PAB, because these forces 80 kN and the reaction force R1 are in the opposite direction. So net amount of the force is 80 minus PAB, that is the 80 minus R1. In the same way, right hand side also we have to calculate. So here observe the force 150 kN is acting and another reaction force of PCD is also acting in the opposite direction in the portion CD. Then net amount of force is acting as the R2 minus 150. So length of the portion BC is 2000 mm and force PBC equal to the 80 minus R1, which is also equal to the R2 minus 150, and the cross section area of the portion BC is the ABC equal to the 1500 mm square. So here observe the nature of the forces are the compressive forces. Next, we will determine the reaction forces R1 and R2. From the statics, to maintain the equilibrium, left hand side forces are equal to the right hand side forces. Here left hand side forces are the R1 and R2. Right hand side forces are the 80 kilonewton and 150 kilonewton. So R1 plus R2 equal to the 80 plus 150, that is the 230 kilonewton. Let's consider this is the equation 1. From the compactability, extension of AB equal to the compression of BC and CD. Here tensile forces are acting on the portion AB, so it will be elongated, and compressive forces are acting on the portion BC and CD, so it will be compressed. Then extension of AB equal to the compression of BC and CD. So that is the deformation of portion AB equal to the deformation of the portion BC and CD, that is delta AB equal to the delta BC plus delta CD. We know the deformation delta equal to the PL by AE. Then this equation we can be written as the PAB LAB divided by AAB into E equal to the PBC LBC divided by ABC E plus PCD LCD divided by ACD into E. So here E will be get the cancel. Then substitute all the values in the above equation. Then this equation we can be written as, so PAB value is the R1. So LAB equal to the 1500. Cross sectional area of the portion AB is the 1000, and so E, and PBC value is the 80 minus R1, and length of the BC is 2000, and cross section area of the BC is the 1500 into Young's modulus E plus PCD is the R2 and LCD is the 1500, ACD is the 2000 into E. So here E will be get the cancel, and also so 2 zeros and 2 zeros, so 2 zeros and the 2 zeros, 2 zeros and the 2 zeros will be get cancelled. Then this equation we can be written as R1 15 divided by 10 equal to the 80 minus R1 into 20 divided by 15 plus R2 15 divided by the 20. So this equation we can be written as the R1 into 1.5 equal to the 80 minus R1, so 20 divided by 15 equal to the 1.333 plus R2 into 15 divided by 20 equal to the 0.75. Then R1 into 1.5 equal to the 80 minus R1 into 1.333 plus R2 into 0.75. So this equation we can be written as 1.333 R1 plus 1.5 R1 equal to the 106.664 plus R2 0.75. So this equation will become the 2.833 R1 equal to the 106.664 plus R2 into 0.75. Let's consider this is the equation 2. Now we will solve the equation 1 and 2. We will get the R1 and R2 values. From the equation 1, we can be written as R1 equal to the 230 minus R2 kilonewtons. Then substitute this R1 value in the equation 2. Then equation 2 will become the 2.833 into 230 minus R2 equal to the 106.664 plus R2 into 0.75. So from this equation we can be written as 2.833 into 230 equal to the 651.59 minus 106.664 equal to the 2.833 R2 plus R2 into 0.75. So from this one we can be written as 554.926 equal to the 3.5833 R2. Then R2 equal to the 152.08 kilonewton. Then substitute R2 value in the equation 1. We will get the R1 value, that is the R1 equal to the 230 minus 152.08, which is equal to the R1 equal to the 77.92 kilonewton. We got the R1 and R2 values. Next we will calculate the forces are acting on the each portion of the bar, that is the PAB, PBC and PCD. So PAB value is the R1. So PAB equal to the R1, which is the 77.92 kilonewton. The nature of the forces is the tensile forces. And next one is the PBC equal to the 80 minus R1, that is the 2.08 kilonewton, and nature of the forces are the compression forces. Next to PCD equal to the R2, which is equal to the 152.08 kilonewton. Nature of the forces are the compression forces. Next we determine the displacement of the portions AB, BC and CD. So that is the delta AB, delta BC and the delta CD. So first we have to calculate the delta AB, which is equal to the PAB LAB divided by AAB into E. So we know the PAB value, LAB value and the cross section area of the portion AB value and Young's modulus value. Then substitute all values in this equation, then we will get the 77.92 kilonewtons, that is the into 10 to the power 3 into LAB, which is equal to the 1500 mm, divided by AAB, cross sectional area is the 1000 and E is the 200 kilonewton mm per mm square, that is the 200 into 10 to the power 3. So here, 10 to the power and the 10 to the power it will be get the cancel, and here double zeros and double zeros also it will be cancelled. So then we can be written as 77.92 into 15 divided by 1000 into 2, which is equal to the 0.584 mm. So this is the elongation. Then we have to use the positive symbol. Next we have to determine the displacement of the portion BC, that is the delta BC, which is equal to the PBC LBC divided by ABC into E. So we know all the values, then substitute, then delta BC will become the 2.08 into 10 to the power 3 into LBC is the length equal to the 2000 mm divided by cross sectional area of the portion BC equal to the 1500 and E value is the 200 into 10 to the power 3. So here, 10 cubed and 10 cubed will be cancelled, and double zeros and double zeros also will be cancelled. So then this equation we can be written as 2.08 into 20 divided by 1500 into 2, which is equal to the 0.014 mm. So here portion BC is the forces are acting as the compressive forces. Then we have to use the deformation is the minus symbol. Next we have to determine the displacement of the portion CD, that is the delta CD equal to the PCD LCD divided by ACD into E. So substitute all the values, then we will get the 152.08 into 10 cube into length of the CD is the 1500 divided by cross section area of the CD is the 2000 into E value is the 200 into 10 cube. So here 10 cube and 10 cube will get cancelled, and double zeros and double zeros also will be cancelled. Then this equation will become the 152.08 into 15 divided by 2000 into 2, which is equal to the 0.5703 mm. And so nature of the forces are acting on the portion CD is the compressive forces. Then we are using the symbol is the, so for the deformation of the CD is the minus. So next we have to determine the displacement at point B and at the point C. So at the point which is equal to the deformation of the portion AB, which is the extension, so it is the delta B, the value equal to the 0.584 mm. And similarly deformation at the point C, which is equal to the deformation of the portion CD, which is equal to the compression of 0.5703 mm. That is, we have to use the symbol minus. So delta C equal to the 0.5703 mm. So this is the solution, and thank you.